Okay, the quotient rule, again, is used when you're trying to find the derivative of a function and you're dividing. So, say I was trying to find the derivative and I have something like f of a all over f of b. So, to find the derivative of a function and you have some sort of division in it, we use the quotient rule, which works like this. Now, I'm going to explain it, and then there's kind of like a quick little way that will help you remember it. I still say it to this day when I'm doing it. But to find our derivative, we're going to take the low. So if you think about our fraction, okay, we've got, this is called the high number and this is called the low number. Again, your numerator and your denominator. So what we're going to do is we're going to take the low number times the derivative of the high number. So let's see here. Subtract the high number times the derivative of the low number, and then all of this is going to be over the low number squared. Now again, this seems hard, this seems a lot like a lot. How, like the saying that we say is low d high minus high d low, and over the square of low we go. So let me say that in full speed. Low d high minus high d low, and over the square of low we go. So that's how we can kind of help ourselves to remember the quotient rule. So if we were to take a function, let's just pick, all right, y equals 5x squared over x to the third plus 1. Again, think about our labels. So 5x squared is my high number, which means if I wanted to find the derivative of my high number, I could use the power rule. So take this 2, bring it out front. So the derivative of this high number is 10x. And then the low number is x to the third plus 1. That's low. And again, using the power rule, the derivative of our low number is going to be 3x squared. So now I have enough information where I could plug some stuff in. So I'm going to say low times derivative of the high, low d high. So x to the third plus 1 times the derivative of the high minus high times derivative of the low, and over the square of low we go. So of course you're going to have, you know, quite a bit of simplifying to go through. So again, I have to use my FOIL technique. Well, not quite. I have to take each term and multiply it here. Same deal here. I have to use my exponents rules. So I'm going to be left with 10x to the fourth plus 10x. And then this is going to be minus 15x to the fourth. And it's all over x to the third plus 1 squared. Now I do see that we have a like term here and a like term here. So we're going to combine those. So our derivative after using the quotient rule is negative 5x to the fourth plus 10x all over x to the third plus 1 squared. Excuse me. A lot of different steps that go into this. Let's do a slightly different one. Take the function f of x equals 2x plus 1 and 3x minus 1. Again, I've got a low number and I've got a high number. So to find my derivative, I'm going to say low times derivative of the high, low d high, 3x minus 1 times derivative of the high. The derivative of the top part here is just going to be a 2, minus high number times derivative of the low, which is just going to be 3, and over the square of low we go. So we can just again start multiplying 6x minus 2 minus 6x minus 3. You could try to factor this out and see if anything else will cancel out. It's not going to in this case. We've got some like terms. Negative 2 minus 3, negative 5 over 3x minus 1 squared. Anytime you can use your exponent rules to, you know, potentially like change the problem so you don't have to use the quotient rule, it's kind of faster, right? If we write this like this, we can just use our power rule and say, all right, I'm going to reduce 2, or I'm going to bring this 2 down. 2 times negative 2 is negative 4. Negative 2 minus 1 is negative 3. So this would equal negative 4 over x to the third. That's much, much faster than using low d high minus high d low, and over the square of low we go. However, it works. If you did that with, you know, 2 being your high number, your derivative of 2 is 0, and x squared being your low number with 2x being your derivative, you would end up getting the exact same answer of negative 4 over x to the third. So to save yourself time, again, it's for your own benefit to try to reduce those or change those so that they are in exponent form. Excuse me. Okay, let's see here. This example is a little bit more intense just because we have to be very careful with our square root signs and our exponents. So again, if I were to find this, the first thing I'm going to do is I'm going to rewrite these two terms. So this is the same as x to the 1/3 plus 2, and this is the same as x to the 2/3 plus x. So now I'm going to use my quotient rule. Low d high minus high d low, and over the square of low we go. So low is x to the 2/3 plus x times the derivative of the high. Again, what am I looking at? I'm looking at this right here. I'm going to move that 1/3 down and then get 1/3 x to the negative 2/3. But I know that I have to change that. So we'll just keep it like that for right now. Minus, let's see here, low d high minus high times the derivative of the low. And the derivative of the low is 2/3 x to the negative 1/3 plus 1. Okay, and then it's all going to be over x to the 2/3 plus x squared. Now, I don't really think much else is going to be, you could simplify this. In this case, again, Sometimes if the directions say do not simplify or just keep your answer, this could be one possible way. So again, if it just said find the derivative, do not simplify, you could stop right here. All right, that's the basics of the quotient rule.